Welcome to Oasis e-learning platform. This is mathematics lesson 6, whereby we are going to look at the ratios and proportions. But last time we looked at how to round off numbers to hundred thousands. But we don't need to talk much about that one. We look at our topic for this time, which is ratios and proportions. So we are going to pick one of them, whereby we shall look at the ratios, and we will define ratios as comparisons of numbers by division. Or someone can say a ratio is a comparison of numbers by division. That one actually means when we are comparing numbers, we need to divide them so that we can compare them very well. So people also do confuse the symbol of ratios. Some do call this one as is to, but this symbol, which is like this, it means 2, as written on the chalkboard here. As we have said, a ratio is a comparison of numbers by division, and the symbol for a ratio is always this one, which is always used in books, and it means 2. So in that case, we also have some facts about ratios. 1. Ratios must have units of measure on them. 2. Ratios must be expressed in the same unit. The third one is ratios must be expressed in their lowest forms or the simplest forms. The fourth fact about ratios is ratios must be expressed out of their total ratio. So those are facts about ratios. So we are going to look at some of the few examples of ratios. We are looking at the first example, which is written here. Number 1. What is the ratio of 20 centimeters to 2 meters? As the other fact has said, ratios must have the same unit. When we look at this question, the other one is talking about centimeters, the other one is talking about meters. But when we look at these two units, meters and centimeters, so when you compare them, meters are a bit bigger than centimeters. So what you have to do is, you first change meters to centimeters, whereby we shall say in 1 meter, this is the example of 1 meter. This roller here, it is 1 meter, but when you look at this roller, it has 100 centimeters. This is the example of 1 meter. So in 1 meter, we have 100 centimeters. But here we have 2 meters. Now, what if we have 2 meters? We shall multiply 2 times 100 centimeters, whereby we shall get 200 centimeters. So if you look at the units now, this one is 20 centimeters, and we have converted this one to also centimeters. It has given us 200 centimeters. Meaning, ratios must be expressed in the same unit. We shall now say we shall now say 20 centimeters to 200 centimeters, whereby this one becomes 20 to 200. As we said, a ratio is a comparison of numbers by division. We need to divide 20 out of 200, whereby we look at the common numbers, which is 0, 0. We divide this one by 2, here 1, 20 divided by 2, we get here 10. We write this one as 1 out of 10. When we look at this one is a fraction. But when you express it as a ratio, it is 1 to 10. This is our first example about ratios. So we have expressed it in its simplest or lowest form. So we can look at the second example, which is express 100 grams as a ratio of 1 kilogram. So if you also look at these two units, we have grams and kilograms. So what we do is we must convert kilograms to grams because grams is a bit smaller than kilograms. Good. So the word kilo means 1,000. If the word kilo means 1,000, now how about kilograms? 1 kilogram. So we shall say 1 kilogram has 1,000 grams. How about it is only 1? So what we do is we now say 100 grams to 1,000 grams, which is 102. We use the simple now, 1,000. We divide 100 out of 1,000. We cross the common number 0, 0. This one crosses with this one here. So we write this one as 1 out of 10. Again, this is as a fraction. As a ratio, we put it as 1 to 10. Because they are saying ratios must be expressed in the same unit. 2. They must be expressed in its lowest or simplest term. That one actually means you divide them, you look at the common factors that can divide the numerator and the denominator. When you divide them and they cannot be divided anymore, that is the meaning of the simplest or the lowest term. This is our second example. So we can look at the third one, which is a rectangle has a length of 24 centimeters and the width of 18 centimeters. What is the ratio of its width to length? So, what you have to do before you start answering is, you first need to check the units. If you look at the length, it is 24 centimeters. You also look at the width is 18 centimeters. As said, they must have the same unit. This one is having centimeters and this one is also having centimeters. So we don't need to convert anything because they have the same unit. We shall just go straight. But what you should do is you master the word very well. Ratio of width to length. It means we start with the width, which is 18 centimeters to 24 centimeters, which is 18 to 24. So we divide 18 out of 24. We look at the common factor that can divide 18 and 24. If you look at 2 can divide these two numbers. Even the 3, 6. The number that can divide these two numbers, where is 6? 18 divided by 6, we shall get here 3. Then 24 divided by 6, we shall get here 4. So, which is 3 out of 4. As the ratio, we write it as 3 to 4. So that is our third example. So with these 3 examples, I hope you'll be able to do these 2 activities I have given you. So they read like this. Number 1, you are going to express 12 to 15 in its simplest form. So yours is just to divide it until it can't be divided anymore. Number 2, what is the ratio of 45 seconds to 1 minute? So when you look at number 2, it is where you are going to look at the units. You first need to convert the other unit to the other one so that you can work it out very well. So with these few questions, I know you will never be defeated. So I really thank you very much for having watched the lesson. Thank you very much.